It's indeed a great pleasure and a privilege and an honor to be the General Chairs for ACM MobiCom 2018. We will take you through the journey of how it all began a year ago. But before we do that, I want to profusely thank all the delegates who've come from different parts of the world. Very special thanks to our keynote speakers, our distinguished guests, and truly, we have participation in MobiCom from all over the globe, and we are delighted. Special thanks to our steering committee members who made this happen. For those who are coming to India for the first time, a very, very special and a warm welcome to New Delhi, India, the capital of India. Probably one of the oldest cities in the world, as far as we recall, and the most historic city in the world. So, again, a very warm welcome to ACM MobiCom 2018. Now, when the conference starts after 1 year of efforts, I won't use the word Herculean for us, but for the entire committee and for all the speakers who gathered here, it's a bit of feeling of nostalgia because behind this conference are tens of thousands of emails, thousands of phone calls, hundreds of meetings, physical meetings, visits to the hotel next door where the banquet is. And finally, you realize that we are here and are delighted. Now, it is nostalgic because the journey of last 1 year has been a very, very interesting journey, as you will see in a short while from now. I'm now going to request my colleague Rohan Narayan Murthy to take you through the journey. Thank you so much.
Thanks, Rajiv. We had an excellent organizing committee, particularly in selection of the papers, led by Jennifer and by Kyle. In fact, the technical program committee have selected this year about 42 papers. In addition to that, we also had excellent chairs who worked very hard. Obviously these are folks who have a full-time job doing other things. Particularly the workshop co-chairs. We have 8 workshops lined up. We have poster co-chairs. We have 48 posters. The demo chair, we have 21 demos. The student research competition chair, of which we have 19 entries. A great job by Vinay Robero, managing our finances. A MobiJob event chair that Swarun led very ably. We have 6 companies being represented. And a whole host of effort done by various folks, including in publicity, in the app, the N2 Women, the registration, the mobile app competition, local arrangements, and a special word of mention to Rohit Verma, who's a doctoral student at IIT Kharagpur, who has really sort of marshaled our website and a lot of our web presence. He's done an outstanding job. We've also had a lot of help with regards to student travel grants, without which, of course, many students would not be here. And an excellent job by the publication co-chairs by Long Fei and Yan Wang. And our advisory committee was extremely helpful, particularly Professor Huzur, as well as Dr. B.M. Baveja, who really helped us put this together. There's a lot of sort of logistics that goes on in Delhi trying to get this together. And that's a big deal for India, and you'll also see in today's keynotes why that's a big deal. So thank you, Victor, and to the steering committee in general for letting India host it this year. Rajiv.
Thank you, Rohan. ACM MobiCom boasts of several events. In fact, we, as you will see in a short while, we really have a problem of plenty, but that's a good news. Now, a special thanks to our workshop co-chairs. The workshop was very ably led by Archana Mishra and Nick. And now what they did was with due diligence and with a lot of effort, they finalized 8 workshops for ACM MobiCom 2018. 4 workshops ended yesterday, and we have 4 more workshops on 2nd November. The workshops that ended yesterday was the workshop on connected vehicles and platooning, very ably led by our chairs over here. Then we had a workshop on Chance, which is Challenge Networks, again led by our colleagues from Germany and Australia. We had the first workshop on complex network system for smart infrastructure called CNET-SYS, which again was a great success with very, indeed excellent keynote speakers, very ably led by Prashant Mishra and Giri Mandyam. And then we had a workshop on millimeter wave networks and sensing, the MMNets workshop, again wonderfully led by Dimitrios and Georg Widmer. As you can see that the program committee are people from all over the globe, and we are indeed extremely grateful that they agreed to sign up for their events. We have 4 workshops coming on 2nd November. Again, wonderful workshops. Please don't miss them. It is the last day of the conference, but please don't miss the FICN workshop, the WinTech workshop, the EdgeTech workshop, which is a very hot area now, and all the areas are wonderful. And thanks to our students, Swadhin Pradhan and Shwetank Kumar Saha, they have, very put a lot of effort in enabling the 10th wireless of the students, by the students, and for the student workshop called S3 workshop. Thanks again to the workshop chairs. There is no conference which is successful without the stellar and Herculean efforts of our volunteers. I think Rohan and I, along with all my organizing committee members, are indeed greatly indebted to the 15 volunteers. Now, of special mention are volunteers from outside India. Observe that there are many volunteers. There are quite a few from the United States. They're from Singapore. We did think that we'll have a truly global character of, in terms of volunteers. Now, it's tough to, when you finalize volunteers, you have to choose very highly energetic colleagues. And I'm glad to share with you that we did finally converge on an excellent team of 15 volunteers. We will, have a formal appreciation during the banquet. Before I hand over to Rohan, as I said, the conference program is absolutely packed. And that's one challenge that Jennifer, Kyle, our TPC coaches, Rohan and I had. So there were two ways to look at it. One was that, there is no time other than the lunch breaks and the dinner breaks. But the other way to look at it is, we are all here from all over the globe. Well, this is the perfect time to learn from the luminaries who gathered here, the stars or the gurus as we call them. So I'm not going to go through that, but from morning to night, there is no break at all in ACM MobiCom 2018. And just as, people, all of us in the team, particularly our TPC chairs, Rohan and I, as excited that we just tried to pack as much as possible, including a panel discussion tomorrow, including, all our various topic preview sessions, which have really gone extremely well, and the list goes on and on and on. So I'm going to hand over to Rohan, but again, just to summarize, the program is completely packed, but you do have time to network during the lunch breaks and, of course, the dinner breaks on morning time. So it's been quite an interesting journey to fill up the program, but with no break at all, no gap at all. Rohan, over to you. Thank you.
So some of the key features for this year are that we have 4 keynote talks that are spread across the next 3 days. There's also an Athena lecture, which we're very privileged to host. We have a special session called Reflecting with Victor that one of our award winners, Teresa, will be taking part in. We also have 2 awardees for the Test of Time Awards. And this whole 5-day conference, we have workshops. As we mentioned, we have 8 workshops, panel discussions, several papers, posters, the student research competition, mobile app competition, the End2Women workshop, 4 tutorials, and so on and so forth. Our keynote speakers for this year are this morning will be Mr. Mukesh Ambani, who's the chairman of Reliance, and also runs perhaps what is one of the most interesting wireless companies on the planet. And today you'll hear later on why. Professor Monica Lam, we are very grateful that she has flown all the way from Stanford, one of our keynote speakers. Professor Kathleen Carley from Carnegie Mellon, Professor Peter Kirsten from London. The Athena lecture for this year will be delivered by Professor Andrea Goldsmith, again from Stanford, and Professor Teresa Meng, who's one of our award winners this year, will be in a session with Victor, reflections along with Victor. So we have a very strong Stanford contingent this year, clearly, and it looks like they're quite happy to meet each other here in India and catch up. Also, we have 8 topic preview sessions led by various subject matter experts. Yesterday we had 4, today we have 2 of these, and tomorrow we have 1, and day after we have 1. These are very interesting, different people doing very interesting work, so we encourage you to attend these. The awards, of course, without mentioning the best paper, which actually I don't think we know, the best paper and the best student paper we do not know, but the ones that are public are Professor Teresa Meng this year is the winner of the SIGMobile Outstanding Contributor Award. Professor Kyle Jamieson is the winner of the SIGMobile Rockstar Award. And the Test of Time Award goes to professors, Professor Don Towsley at UMass Amherst, and to Victor as well. Rajiv?
Thanks. We're extremely grateful to our sponsors. Special, great appreciation for SIGMobile and NSF. They've been amazingly, extremely supportive of the conference. Now, I think I'd like to mention here that we work with several organizations across the globe. But when you work with ACM SigMobile, it's special. They're so dedicated. You send a mail and you get a response in less than 24 hours, but sometimes immediate. So we're extremely grateful to SigMobile and NSF for sponsoring the conference. A special mention to our gold sponsor, Infosys. One of the challenges that we had was that if we really had to bring a lot of students and faculty from India, we were clear that we'll have to help them in terms of providing scholarships, right? So by providing scholarship, the registration fees for them reduces significantly and they're able to attend the conference. So we have been successful in doing that to a large extent, and thanks to our gold sponsor Infosys, silver sponsors Cisco, Microsoft, and Google, they've gone out of their way to support the conference, and we're indeed extremely delighted and thankful to them. Special mention of the support we received from the Murthy Foundation for supporting student scholarship. So Rohan has played a major role here in getting funding from the Murthy Foundation. They're extremely, well known in the country, great altruism and philanthropy, and they support a lot of wonderful causes in India and abroad. Special mention to CommsNet Association. Many of you may not know that many of us run the CommsNet conference in January in Bangalore. It has become a flagship conference of India, and that association now has funding for even other top-notch events. Dr. Praveen Bhagwat leads on introduction. He's the CTO of Mojo Networks. The entire Wi-Fi of this hotel, everywhere is Mojo Networks, courtesy Mojo Networks. So thanks, Praveen, if you're in the room, for all your support, and his team has done a wonderful job. VideoCan is our content partner. We have other partners such as VS World and Dreamcast. The entire conference, for your information, is being streamed live across the globe. All the talks have been recorded from morning to night. Of course, we'll get all the permissions in time. But from morning to night, we have live video streaming. We have, videography for every talk. So again, thanking all our colleagues over here. And before we wind up and invite our technical program committee co-chairs on the stage, a special mention for our colleagues from the ministry, Dr. B.M. Baveja, who was here last night. They played a major role in getting approvals. It is quite a challenge to get approvals, the visa approvals, because it requires getting approval from Ministry of External Affairs, Home Affairs, and the nodal ministry called Electronics and IT. So thanks to the entire team at the ministry, all these three ministries, for helping us and being extremely supportive. So thanks again, and a very warm welcome to New Delhi. At this point of time, I'm going to invite two very highly accomplished researchers, Professor Kyle Jameson from Princeton University, and Professor Jennifer Chen from Rutgers University, who extremely, very ably, led the entire MobiCom 2018 as technical program committee co-chairs. So over to Kyle and Jennifer. Thank you so much.
All right. Good morning, everyone. And I think Jennifer and I would like to add our welcome to MobiCom 2018. We are so excited to be here. Jennifer and I are the TPC, the Technical Program Committee co-chairs, and our role in the conference was to select the papers that would appear in the main conference program. And so we'd like to give you some kind of insight into how that happened this year at MobiCom 2018. So we would like to start off by saying thank you so much to the program committee, the technical program committee, who was responsible for putting in so much hard work to select all these papers. So for those of the TPC who are present in the room, would you like to stand up? And let's have a round of applause for the TPC members. Our TPC this year was, the theme was really bigger, bigger, bigger. So there were 63 members on the TPC representing 12 countries. And the structure for how it was run was called All Heavy. And what that means is that all the TPC members had a full heavy load of reviewing many, many papers for the conference. And then all of them flew and traveled to Rutgers University to debate the papers in person, face to face, at the TPC meeting. And what this arrangement allowed us to do as those of you who submitted to MobiCom 2018, was support more reviews per paper than ever before, and hopefully give you the best possible outcome. A bit more detail on the process. This year we had 187 paper submissions. Of those paper submissions, all of them got at least 4 reviews in the first round, and some fraction of which were promoted to round 2. Of those, another fraction were promoted to round 3. And in these rounds of reviewing, these reviews were happening online, with each papers that survived to later rounds getting more and more reviews. At that point, the PC meeting happened, and we discussed 69 papers in person. I'm happy to report that the debate was really vigorous and heated, and I think overall, I think I am, and Jennifer, very pleased with the outcome. The result that we are so happy with is that we accepted if not a record high, a near record high of 42 papers to MobiCom this year, which is quite a good, healthy number. And we fit those into 10 technical sessions that Rajiv and Rohan mentioned are packing your schedule. So we hope the energy level here is extremely high. To put this into perspective, over the years, if you look at the number of submissions MobiCom has gotten, it's an interesting curve. You can see, right, that we had a period of rapid growth, starting in 96, 95, when MobiCom started, and then kind of peaking in around 2004, 2005. And as many of you in the room know, our community, the SIG-Mobile community, kind of diversified conferences. For example, MobiSys and Census formed, and that kind of figures into the picture here. But overall, our growth has tapered, and we're not satisfied with the status quo. While MobiCom is always going to be, while mobile computing and networking will always be an important key field, we want it hot and growing rapidly. And so just some thoughts about how we might reignite that kind of growth in our field. One kind of answer to that that we would like to kind of put to you to think about is the technical theme of this year's conference, which is kind of you learning. Not machine learning, but you learning. So you learning new things, and we would like you to approach this with a mindset that, check your ego at the door. Start from 0, as if you were 0, and come at the events that we have and the packed schedule that we have for you from a perspective of you want to learn and soak up as much new information as possible. And this not only applies to junior researchers who may be in the audience, but also the more senior members of our community. And so this year we've introduced these topic preview sessions, which began yesterday. We had 4 of them in parallel. We're really happy with the attendance. And so we've picked out these kind of boutique-ish, hot new topics for MobiCom that many of you will be highly excited to learn more about, and I know I am, for one. We really encourage you to keep attending these topic preview sessions. They're coming up in the lunch breaks. They've been carefully scheduled to be before the relevant paper session in the main conference. And the idea is that you're going to go to this, you'll learn about the sub area, not specifically about the papers that you'll see presented, but you'll learn the background so that you can appreciate the papers much more. And so we highly, highly encourage you to go to topic preview sessions. And with that, I'll hand it over to Jennifer.
Just to put you into perspective, we want to show you that the authors from accepted papers, what they come from around the world. So you could see that a significant amount of people, the authors, they come from North America area. And then we also have active researchers from Europe and also Asia. So to take a closer look, we'll see that we're also going to do the statistics for the attendees here, and we'll see that, okay, what are the geographic distributions after the conference. We'll share the information with you for the attendees. So we're going to put this into perspective to see that what are the authors come from, what are the paper submissions, and also what are the attendees. And by using this, okay, we like to see that going forward, what are the areas in terms of both the technical area and also geographic area. We like to see the growth of MobiCom. And just to, we feel that, okay, in addition to the 10 technical sessions, as the general chairs talked about, that we have really exciting keynote talks and brought by now outstanding keynote speakers. So both Kyle and I would like to talk some more about their research and also the talks that they are going to give to us. So it will cover a broad range of areas in different perspective. So that is also why we say that we want to put it into the Euro Learning for this conference. And we're going to have Mr. Mukesh Abani from Reliance Industries, and he's the chairman and also the technical manager from Reliance. And as I heard that he's the Bill Gates in India, and he transformed the digital services business in India and also around the world. So he's going to share his successful experiences in the digital services area, and also he's going to talk about his vision in the opportunities that could be brought by Reliance in both digital service business and also in many other areas. And this afternoon, we are going to have Dr. Monica Lam. She's from computer science at Stanford University. She's going to tell us what is the importance about the virtual assistant systems? And we see that almost every home now we have one of the virtual assistant systems. And she's going to discuss why it is important we like to have open source virtual assistant systems. And she will show us the initial efforts that her research have been put into toward this goal. And then in the later days, we're going to have Dr. Kathleen Colley from Carnegie Mellon University. She's going to talk about, okay, what is social cybersecurity? So this is a very interesting area, and previously, okay, we haven't really thought how to put social aspects tied together with the cybersecurity area. So she's going to talk about the nature, the challenges, and also the promise that the social cybersecurity could bring to us. And then we're going to have Dr. Peter Kirstein from University College London, and he's going to talk about the activities that involved in setting up the international internet and its precursors. And with the consideration not only on the technical aspects, but also involve the political climate during the internet growth. So that should be a very interesting history that we can look back to put internet together. And going forward, we also have the ACM SIG Mobile winners, and we are going to have Dr. Adrian Goldsmith from electrical engineering at Stanford University, and she is the ACM Athena Lecturer Award winner, and she's been in the wireless area so active and with many prestigious awards and research activities. So she's going to bring us with her vision in the future wireless networks, and we're going to see that what are the innovations and the breakthroughs. She will talk about how to see that we can realize the goal of the future wireless networks in the coming decade. Okay. And we're also going to have Dr. Kyle Jamieson. He is the he's the ACM SIGMobile Rockstar Award winner, and he's going to give us interesting Rockstar talk, which should be a very exciting one. And also Dr. Teresa Meng from Electrical Engineering from Stanford University, and she's going to have an interesting session of reflecting with Victor Barra with the fireside talk. So we'll see that how it goes. Okay, it should be also a very eye-catching session. So we're also going to have the two Test of Time Award winner speakers. One is Dr. Don Tousley from UMass Amherst and Dr. Victor Barra from Microsoft Research. I heard Victor was born in Delhi, so I think it would be very special for him to give the Test of Time Award talk here. Okay. And finally, we're also going to have the panel discussion, and we bring together the researchers from networking systems and also the artificial intelligence and machine learning. And as Kyle and I expect that we like the theme to become you learning, okay, after we debate about the hammer and the nail. So probably we feel that we really want to have a combination of the artificial intelligence, machine learning. When they apply to networking systems, probably we are going to the theme of you learning here at MobiCom. So again, welcome to Delhi, and I hope in the next few days, okay, you're going to witness and go through the interesting program that we put together in MobiCom 2018. So we're going to enjoy the program here together. Okay, so next I'd like to invite Dr. Thank you. Okay, so next we'd like to invite Dr. Marco Gruteser, ACM SIGMobile Chair. So he's going to give us the presentation.
Thank you, Jennifer. As Chair of SIGMobile, it's a great pleasure to welcome you here all in New Delhi and to present two of SIGMobile's most significant awards. The first award is the SIGMobile Outstanding Contribution Award. It's our most significant research award that can be presented either for a single accomplishment or for a lifetime of achievement. And over the years, we've had a number of very distinguished recipients of this award. These recipients, together with Ed Knightley, our SIGMobile Awards Chair, form the selection committee for this award that evaluate nominations and choose the winner. And this year's winner has a PhD from UC Berkeley, has been a professor at Stanford University for a number of years, has been a member of the US National Academy of Engineering, has received a number of other important awards, and has been perhaps most of interest to us here, the founder and director of Asterisk Communications. She has received too many accolades for me to mention, but her work, for example, has been called the main driver for today's low-cost, high-performance Wi-Fi that we all enjoy around the globe. These are pioneering contributions, and please join me in congratulating Teresa Meng. Please come up. Please feel free to come up on the stage for a moment. For fundamental contributions to the hardware design and implementation for wireless local area networks, including the development of faster, lower power, and cheaper Wi-Fi. Congratulations.
Thank you, Marco.
You wanted to say a few words.
Yeah. I really appreciate coming to MobiCom to receive this award. I'm especially happy because two of my friends from Stanford, Andrea Goldsmith and Monica Lam, are also giving keynote and Athena lecture at the conference. What has made this award possible for me was the outstanding engineering team at Atheros. To accomplish something like this requires many disciplines working together. So I'd like to thank David Su, who headed our analog team, John Thompson for his digital effort, and Bill McFarlane for leading our system design group. I will be talking to Victor tomorrow, having a Q&A session to answer any questions that you may have. Thank you very much again. Thanks.
The second award is our Rockstar Award. This is our award for early career contributions to the field of mobile computing. And we've also had a number of very accomplished winners of this award over the years. Many of them are here in this audience. And again, these awardees, together with some senior members of the research community under the leadership of Ed Knightley, form the selection committee for this Rockstar Award. And the winner of the Rockstar Award is known for a series of amazing accomplishments and papers in our community. These include partial packet recovery for more reliable wireless transmissions, array track for amazingly accurate localization, and phaser for practical signal processing, phased array signal processing on deployed Wi-Fi access points. His contributions have been called deep and rigorous, groundbreaking, truly imaginative researcher. Please join me in congratulating Kyle Jamieson for his early career contribution. He happens to be on stage already. This was not planned by any means, but it's an honor to congratulate Kyle. So I believe next is a video session. He wants to say if you want to go.
I'll just really quickly say thank you so much, and it's really an honor to stand beside all the previous awardees of the Rockstar Award. And with that, let's continue.
Thank you. All right. I believe next up is a video session. Is that true?
Yes.
Wireless networks today are highly congested, and to support the current and future traffic demands, next-generation standards are moving to higher frequency millimeter wave bands with huge bandwidths. These links are inherently directional, which introduces the challenge that devices need radar-like beam scans to find their intended receivers before they can communicate, and this introduces a high overhead process. This is especially problematic for mobile devices, which may require a new scan every time they move, leading to frequently broken links and angry users. We present Lightsteer, where our key idea is to repurpose existing indicator lights on wireless access points to get direction estimates using light sensor measurements without requiring any in-band beam scans. We show that with Lightsteer, devices can continuously adapt their beams with passive light sensing, vastly improving throughput for different indoor mobility patterns.
Network slicing exploits virtualized instances of a same physical mobile network to deploy slices that are tailored to the requirements of different services. Slices can cover end-to-end network functions or just part of those, enabling customized support for services at different depth. However, customization requires dedicating network resources to individual slices, with a cost in terms of efficiency. We run a first data-driven study of this cost by considering real-world service demands for different kinds of resources, from radio access to the network core, and multiple timescales of dynamic resource orchestration. For each setting, we model slice QoS specifications and compute the total amount of required resources. Normalizing against a perfect sharing benchmark returns the final efficiency. Our results showed that slicing efficiency can be as low as 15% at the network edge and 65% at the core, and swift dynamic resource management can improve these figures.
Users nowadays interact with many devices, and the interaction times with each device become shorter and shorter. It is therefore desirable to have a convenient yet secure solution for user identification and authentication. We propose body-guided communications to authenticate every touch when users interact with devices. A hardware token, worn on the user's body, interacts with the receiver embedded inside the touch device through a body-guided channel established when the user touches the device. The token has two electrodes that resistively couple, and the touch device has an electrode that capacitively couples with the user body. Our technique confines the channel strictly to the body path between the token and the touch device. The signal received at the intended receiver is much stronger than that received at an adversary's receiver and other places. With a common length identification code, our prototype is able to authenticate touches that are longer than 300 milliseconds. Please find more details in our paper.
Raven improves interactive latency for vehicle-to-infrastructure communication by strategically sending data over multiple networks. Do you often notice that your favorite apps are sluggish when used in a moving vehicle? Our study of V2I connectivity reveals why. Both cellular and Wi-Fi networks exhibit unpredictable variation in round-trip time, and latency spikes are extremely high at tail of the distribution. Today's strategies that attempts to select the optimal network at any given time are fragile. Raven recognizes network conditions are inherently difficult to predict and instead opts for stability. It sends small interactive data over multiple networks when it's unsure which network will perform the best. This lets one network mask unpredictable latency spikes in another. In live vehicle experiments, Raven improves the application response time by 3.4.
Hi, let's talk about our experience in measuring roaming in Europe. Roam Like Home is the initiative of the European Commission to end the levy of extra charges when roaming within the European region. People are able to use data services more freely with the same quality of services when at home. Using a dedicated Moro platform, Moro Roaming, we perform an extensive, large-scale measurement study to understand the roaming ecosystem in Europe. The platform integrates dedicated measurement hardware that we deploy in 6 different countries, covering a total of 16 mobile network operators. And we distributed one roaming supporting SIM in each of the countries we cover. The platform is also composed by a scheduler that queries for resources, select nodes, and launches different tasks in the platform simultaneously. With Moro Roaming, we identify the roaming topology architecture. We characterize roaming operation and network performance, evaluate the impact of VoIP and web application, and study content discrimination. Happy roaming to everybody!
Apple Wireless Direct Link is an undocumented Wi-Fi-based ad hoc protocol which is deployed on more than 1 billion Apple devices, including the iPhone, and enables popular device-to-device services such as AirDrop and AirPlay. We are the first to reverse engineer and publicly document this protocol, which will allow security audits and enable platform interoperability. In Apple Wireless Direct Link, each node announces a sequence of so-called availability windows, indicating its readiness to communicate with others on a specific channel. An elected master node synchronizes these sequences, providing direct communication. Outside the availability windows, nodes can communicate with an access point on a different channel, or could turn the Wi-Fi radio off to save energy. In our paper, we also conduct experiments to assess the protocol's performance and publish an open-source Wireshark dissector. If you want to learn more, join our talk at MobiCom 2018 and don't miss our demo showcasing an Apple Wireless Direct Link prototype for Linux.
Millimeter wave 802.11ad consumer devices use small phased antenna arrays to achieve a high antenna gain and thus data rates of multiple gigabits per second with only a single RF chain. To configure the antenna array, devices probe a fixed set of predefined beam patterns to find the one pattern that provides the highest gain towards the receiver. This approach is low in complexity but leads to suboptimal antenna steering. Instead, we measure the wireless channel to design beam patterns adapted to the current channel conditions. This is more difficult with a phased array than, for example, conventional MIMO, since devices only have a single RF chain and consecutive packet transmissions are not phase coherent. We design an algorithm that measures the SNR of custom probing beam patterns with specific phase shifts that reveal the complex channel state. We implement this approach on off-the-shelf 802.11ad devices to compute a transmit beam pattern that aligns the phases of all antenna elements and maximizes the signal strength at the receiver. Our beam patterns provide a significant throughput gain and improved coverage.
This video shows how to use ambient electromagnetic signals to simultaneously localize and map the indoor environment. EM signals radiated from ambient power networks can form different magnetic belts depending on the nearby power line layouts. We observe that such EMF are especially informative and can be used as positioning cues. As we can see in the three loops walking a building, although the trajectory reported from the inertial sensors drifts, the EMF features are stable in the same location and discriminative in distinct locations. A bespoke detection approach based on EMF is proposed to mine the potential loop closures. The curated EMF loop closures can accurately review the underlying floor plan from drifted inertial trajectories and backtrace the past locations. For more details, please see our paper at MobiCom 2018. Thanks for watching.
What if by tracking our eye movement, we can optimize graphic rendering in augmented reality or monitor our health? We present a wearable eye tracker on glasses to do all that, all without a battery. It works by sensing how your eye reflects light using sensors around the eye. Because the pupil absorbs light, its movement and size variations change the reflected light that the sensors detect. Multiple near-infrared emitters sequentially shine a short, imperceptible light beam to the eye. Sensor data under each light source are aggregated to infer pupil size and position. Because our pupil moves in jerks, most pupil statuses are predictable. Our system detects and adapts to various eye movements to save energy without sacrificing accuracy. Our prototype achieves some millimeter tracking accuracy under various user activities. Above all, it harvests energy from ambient light in various conditions, supporting the whole system without a battery.
This video describes V-Skin from Nanjing University. Similar to a layer of skin on the surfaces of the mobile device, V-Skin can sense touch gestures, like swiping, scrolling and tapping, on the surface of the device. V-Skin achieves comparable usability to the touch screen. Users can smoothly perform the scrolling and swiping gesture to control the phone on the back of the devices. The key idea of V-Skin is that it separates the structure-borne and the airborne sound signals based on the sound propagation delay to sense the touch gestures. Given the high speed of sound for the structure-borne sound, the structure sound paths arrive microphone first. The line-of-sight air paths have longer delays than the structure paths due to the slower speed of sound in the air. The reflection air paths arrive after the line-of-sight air paths due to the longer path length. For more information, please refer to our work which will appear in MobiCom 2018.
Inertial measurement units are often used to track the rotation of mobile devices and objects in two steps. First, the accelerometer measures the vertical gravity direction so they understand the tilt of the device, say 45 degrees. After that, the magnetometer measures the north direction so they also know the heading angle, say 20 degrees. Tilt and heading together define the rotation of the device. But one challenge is that when the device is moving, the accelerometer will be polluted by the linear motion, so it does not measure the tilt angle correctly. The heading angle will also be wrong. We aim to mitigate this issue with two observations. First, we observe that keeping track of the 3D magnetic vector can help reduce the rotation error. Second, with motion models, we can better estimate the true gravity direction. For more details of the paper, please visit our website below.
X-Tandem is the first multi-hop backscatter system that can provide path diversity and robustness. Tags can do relay for each other and embed their information together in a single Wi-Fi packet. This prototype demonstrates a 2-hop backscatter system. With a size like a card, our tag prototype has FPGA-based modulation circuits and free pins to connect external IoT sensors. We can see the excitation signal on channel 1, the first hop signal on channel 7, and the second hop signal on channel 13. The first hop tag transmits a temperature sensor's data. The second hop tag transmits a digital timer's data.
present surface MIMO, a technique that enables MIMO communication between small devices via surfaces coated with conductive paint or covered with conductive cloth. These surfaces act as an additional spatial path that enables MIMO throughput gains of 2.6 to 3 times. With this technique, 2 single antenna smartphones can rapidly share large files like HD videos by being in contact with the same surface. A laptop can rapidly back up files to an external hard drive. The wideband nature of conductive surfaces can be leveraged to support communication at up to 1.3 gigabits per second. A virtual reality headset can stream video through a hoodie's conductive cloth to a wearable pack. HD cameras and walls coated with conductive paint can stream video to a plugged-in hub.
We present Rainbow Light. The key idea of Rainbow Light is a very lightweight and efficient anchor design. When observed from different directions, the anchor shows different color. The incident light generates 2 bunches of refraction light through by refrigerant material. Those 2 lights will cause interference after polarizer P2 and shows corresponding color. When the position of camera changes, the incident angle changes. Accordingly, the anchor shows different colors. Rainbow Light derives angle from anchor color and achieve localization with multiple anchors. To evaluate Rainbow Light, we build an automatic testing platform with a 3D sliding rail and put mobile phone on it. The mobile phone can move in 3D space on the rail. We can draw the trajectory of the mobile phone moving. Experiment shows Rainbow Light has a nice precision. The anchor can work with lamp off. We can stick anchor even on the window or on the wall. For more details, please refer to our paper in ACM MobiCom 2018.